Dear viewers, today we are in our other episode of Transformations. We are going to continue on to discussing with you the topic transformations. Under transformations, there is a general case called general transformations, and under general transformations, we mainly focus on to relating, that is to say, what I would call the relationship between the matrix, the relationship between the matrix of transformation, the relationship between the matrix of transformation and the area scale factor. This is famously denoted as ASF. Area scale factor, in simple terms, it may mean the ratio of the area of the image divided by the area of the object. Ratio is automatically division. So area scale factor, it implies we are going to relate the areas, one of the object with that of the image. Take a case in question where we looked at, say, a point A as our object, and it is transformed to become the image. Meaning, if A is the object and its image is A prime, suppose this has an area and this image has an area, the relationship between the areas is what we call the area scale factor. Now, the transformation matrix that pushes us from the object to the image is what we want to incorporate in our relationship. Secondly, outside that relationship, we have what we call the combined transformation case. Combined transformation or transformations. Combined transformations, here we mean that the object under consideration, for example, if it's a triangle ABC and it is mapped onto A prime, B prime, C prime, for example, then it further mapped onto A double prime, B double prime, C double prime as the second image. By transformation, there is a matrix that shifts us from the object to the first image. There is also a matrix that shifts us from the first image to the second image. That movement is what we call a transformation from the object through the first image onto the second image. Now, the question is, dear viewers, what is a combined transformation? A combined transformation is that transition directly from the object and someone lands to the second image. That transition directly from the second image directly back onto the object. That transition directly is what we call a combined transformation. And a combined transformations is where you're asked as a student to find a single matrix that maps you from the object directly onto the second image. And I want to mention that the matrices T1 and T2 map us from the object to the second image this way. I want to bring in the special terminologies. Matrix T1 maps the object onto the first image. I repeat, matrix T1 maps us from the object onto the first image, followed by T2 that maps us from the first image to the second image. That describes the first arrow. that describes the first arrow. And dear viewers, you will allow me today in this episode to make a simple demonstration about that first arrow. Only about that first. Dear viewers, we want to demonstrate now the transition from the object directly to the second image. That is arrow number 1. Now my colleague Elizabeth comes as T1 that maps us from the object to the first image, followed by my friend Lynn, who comes as T2 that is pushing us from the first image to the second image. You can pause there. Now when you look at the two transformation matrices, from me who is standing where they pushed the object from to put it at the first image, and finally due to Lynn it went to the second image, we notice that actually at the end of the transformation, dear viewers, it is T2 that is seen to come first, then T1. That's why we say that in the combined transformation from the object to the second image, the single transformation in our subject here that we call T3 is given by T2 times T1. Why? It's T1 followed by T2 in the transformation, combined transformation to mention from the object directly onto the second image. Thanks for that demonstration. You can have the seats. We have seen that the matrix that maps us from the object directed to the second image is the product of actually. Now, I normally tell students that this is the last matrix times the first matrix. However, I wanted us to get it in practical situations. So, I want to mention that it is usual matrices. When someone wants to take the reverse process in matrices, we call this the inverse. You simply get the inverse of matrix T1. In the reverse process, from the second image back to the first image, you simply get the inverse of matrix T2. And likewise, from the second image to back onto the object, someone will simply get the inverse of T3. This means our generated matrix T2 times T1 is the inverse. You obtain in order. This is another combined statement. In order to move from the second image directly, combined transformation, second image directly back to the object. Dear viewers, you take the inverse of the product of the two matrices you got when moving from the object to the second image. Without much ado, I want to start off with the examples. Dear viewers, in our example, we have vertices of a triangle, and this triangle has an area. It's mapped onto the first image, followed by a certain matrix onto the second image, as detailed here. So, in the solution, it's important to begin with a simple sketch. The triangle is PQR. It's mapped onto the first image, P prime, Q prime, R prime, and mapped onto the second image. That is P double prime, Q double prime, R double prime. This object we have used is a triangle. You never know, in any question it can be a trapezium, a rectangle, any figure. Remain with the concept at hand. The matrix that maps first is M, then followed by N. It's the conceptual statement. Followed by, this is the concept. Followed by. Now, in part A, we are told to describe matrix N. If you're careful, in the question you will notice that n is given as 2002. This takes us back to transformation part 1, where we did enlargements from. So if you have not yet subscribed, check on to our YouTube channel. Transformations part 1, we discussed enlargements, where we say that any enlargement matrix where the center of enlargement is the origin, it's given as K or K. So this matrix is in this form. When describing, we just want the student to tell us that this is an enlargement matrix. The description therefore is N is an enlargement matrix. Is an enlargement matrix. Is an enlargement matrix about the center is what we are mentioning, about the origin, about 0, 0, with a scale factor, with a scale factor of 2. With a scale factor of 2. You can add on, normally with some people add on that maps the first image. If you're careful on our illustration, you can see that A is what maps us from the first image to the second image. N is that matrix that maps us from the first image to the second image. So you can add on and say with scale factor 2 that maps us from the first image to the second image. Under part B, we are told to find the area. In part B, we are told to find the area of P prime, Q prime, R prime. This is now the concept I mentioned first. Under part B, we want to find the area of the first image. Now, the object area is known. The object area is known. The object area is known, that is 21 units squared, which is mapped onto the first image. It's mapped onto the first image whose area we don't know. We can call it A1, and the area of the object we can call it A0. So the matrix in between here is N. The relationship I mentioned in the introduction in this episode states that the determinant of the transformation matrix is equal to the area scale factor. Is equal to the area scale factor. The determinant, therefore, if we transform our approach to the question, it's the determinant of matrix M, which is equal to area scale factor. I told you it's the ratio of the area of the image, which we have as A1 over the area of the object. Now, we are told that this matrix M in the question, we are told that M is 1, 3. We are told that M is 1, 3, negative 2, 4. That is the matrix M. So its determinant becomes the product, if you are careful, product of the leading diagonal, 1 times 4 minus the product of the minor diagonal, 3 times negative 2, which is equal to area of the image. We don't know the area of the image. Actually, the question wants the area of triangle P prime, Q prime, R prime. Area of triangle P prime, Q prime, R prime, which in my demonstration today I'm representing as A1. However, the area of the object N0, for it we have it, area N0 is given as 21. And with what we see now, you're clearly left with finding the area of the image. This image, by the way, it's vertices a P prime, Q prime, R prime, if you want to label. This is 4 minus negative 6, which is equal to A1 over 21. 4 plus 6 is 10, which is equal to A1 out of 20. Out of 21. When you cross multiply, 1 times A1 gives me our image area, A1, then 10 times 21, 10 times 21, that gives me 210. Therefore, the area required is 210 units squared. When you look at the next part, that is part C, they want us to determine the coordinates of the first image and the second image. That's what is denoted as P prime, Q prime, R prime, P double prime, Q double prime, and R double prime. We discussed in the previous parts of transformation, dear viewers, that are on our YouTube channel. We discussed how to get an image when you're given a matrix of transformation, and currently you have the two matrices. So the approach remains as we discussed it before. Matrix of transformation times the object matrix times the object matrix times the object matrix. The resultant is the image. The resultant is the image matrix. So the concept here is when you want to get the first image, the matrix will be N. The object coordinates will be the coordinates of P, Q, and R, following the previous parts. I'm very sure with the discussions I had with you in the previous parts, you can handle how to get these images. Similarly, when looking for the coordinates of the second image, now it's where I always emphasize, to get the coordinates of the second image, the object is now the first image. It's very important. In the transition from the first image to the second image, the object is now the first image. You're moving from the first image to the second image. The matrix will be N, will be substituted in the same method. The matrix will be N, the object now will be P prime, Q prime, R prime, giving us the image as P double prime, Q double prime, R double prime. You will do accordingly as we discussed in the previous parts, which we have uploaded on our YouTube channel. Dear viewers, I want us to discuss together the last bit of the question. Find the single transformation matrix. Find a single matrix that would map. Find a single matrix that would map. Single matrix. Subsection we are doing is called combined transformation. Single matrix that would map one. The single matrix that would map the object directly onto the second image. The matrix single that would map the second image back onto the object. Now, in that concept, that's when we employ our knowledge we have demonstrated using, don't forget, I brought in my colleague Elizabeth and my sister, friend, very good friend Lynn. They told us that the single matrix, remember, we got it together, that the single matrix is given by T2 times T1. This is one that maps us from the object directly onto the second image. Our T2 is the matrix in this diagram. Our T2 is the matrix N. I didn't want to mention it when the viewer is not seeing. The matrix N is T2. Matrix N becomes T1. So, the single matrix will be A times N. Last matrix times the first matrix. In the movement from the object directly to the second image, this last matrix times the first matrix. So we'll have this as N times M, where N, we know it, N is given as 2002 multiplied by M, which we have as 13-24. We follow the pattern row by column. I'm very certain that if you've been attending the previous parts, which you can still visit on the YouTube channel. Following the pattern row by column, we are reaching the climax of the topic, so there are some instances that I leave to you, dear viewers, to give me feedback. Follow the pattern row by column to obtain this single matrix. This single matrix of transformation, we can call it T3. We can call it T3. Finally, obtain for me that matrix. It will be the single matrix. Now, the matrix that will suit Roman 2, as I end, I'm going to just mention the matrix that suits Roman 2 is simply the inverse of T3 that we have just explained in part D, Roman 1. So, in part D, Roman 2, the second image back onto the object's matrix will simply be the inverse of the matrix we have obtained in Roman 1. It's a very important idea. So, dear viewer, take yourself through the process, obtain this matrix as I've guided you. To get the matrix in this case, find the inverse of the matrix in Roman 1 so that you can suit that. I'm going to add on some practice exercise that is going to help you practice the concept. Don't forget to subscribe to our YouTube channel. Follow us on your Facebook, on WhatsApp. My numbers are there, and for any inquiry, reach me through that WhatsApp number.